Well, hey everyone, and welcome back to the next tutorial in the series on formations. So real quick, before we get into the next formation, I want to go over real quick what happened in the last video, how we got the instantiation of a circle, like this. So I want to go over the math again really quick to make sure I get the point across of how all this comes together. So the circumference of a circle is 2 times pi, which is 6 point something 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 radians. This is the full circumference of a circle. We know we want to generate a circle, so that's why we use this formula 2 times pi. We divide it by 10 because that's the amount of spheres we actually want to generate. That's how many pieces of this pie you could say. So you have a whole circle, which is a pie, and then you have you want to give out 10 pieces of that pie for people to eat. Essentially, this is how many pieces of this pie you want, and then you multiply it times the index in here to give it an angle. When you come down here, you want to get the cosine of that angle because you want to get the adjacent side of that angle. And on the y, we want to get the opposite side of that angle, that number. So we're going to get the use sine to get the opposite of it. So right here, this 1.5 literally just means how far away do you want these to be from one another. We want to give them a bit of an offset for one another, and then that's what we did here. That gives you your x and your y position, so we just add it to the target position that we had before, set it here, and then we give the instance that we instantiated this position, and it just populates them. So, okay, so now we're going to go ahead and finish with this one. We're going to go and do a square formation. So, go in here, we'll make a private void square formation. Oh, too many. Okay. So we'll go ahead and get a vector 3 going again. And it's going to be another target position. And we're going to be setting it to vector 3.0 again. Okay. Now in a real game, depending on where you want this to be your formation to start, that's where you want to go with that target position. That's essentially what's going on there. So let's see. Okay. So we're going to go and make a local variable, a counter, and we'll set it to -1. Then we're going to come down here. We're going to make a float. We're going to get the square root of mathf.square of, and then how many spheres are we going to have in this formation? Well, you know what? Let's do 10 again. So put 10 here. So square root of 10 is going to give 3 dot and a bunch of numbers from there. So with that, we want to go and get the x position we're going to start at, which is going to be target position dot 0. Okay, and I'll tell you what these variables are for. Dot x, excuse me, in a moment. So now let's go back here. Double tap tab, and you get this. We're going to come back in here. How many times we're going to be looping? We're going to be looping 10. And we're going to come into here. And we're going to go ahead and we're going to create an instance of our game object prefab. Okay, so we just instantiated an object. Now we're going to go ahead and increase counter plus plus. Okay, and we're going to go target position, set to new vector 3, target position, dot x, target position, dot y, and we'll just go ahead and set 0 for the z-axis. Right now, we're just going to make a square formation to where it shows on the screen x and y position. Okay, and then what we'll do here is we're going to say if counter is equal to mathf dot floor square root. We're going to set counter back to 0. And we're going to set the target position's x position back to where we started from. And then we set the instance transform position to the target position. Okay, so what's happening here? Okay, so visualize this with me for a moment, okay? Draw this out right here. Okay. Okay, so let's say right here, we're going to be drawing 10 objects, correct? So basically, think of it as 10 spheres. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spheres. Well, we need to find a way to show this in a grid formation. So naturally, if this was 9, you get the square root of 9, you're going to have 3. So that's essentially a 3 by 3 grid. 3 times 3 is 9. So essentially that would look like this. Like this. That's essentially what you would want to display on the screen if you have 9. But we have 10, so we would want it to do. So we're gonna have it look. The way it's gonna generate in the game, it's gonna go 1, 2, 3, 1, 2, 3, 1, 2, 3, and then it's gonna have 1 up here. So this is essentially what it's going to look like, the end product. Well, the way we get this formation is first we make this counter variable set to -1. Okay. We're going to get the square root of 10. It's going to be 3 and some change. Well, that 3 is going to say, hey, how many do I want per line? I want 3 objects per line. So we'll get the square root, and it comes down to 3. Okay? We're going to say the starting x is going to be where the first target position was. It'll be 0 for us. So we're going to come into here. We're going to instantiate a prefab. Counter is going to go up by 1. So now counter is no longer -1, it's actually 0. So it's going to get the target position, it's going to say, hey, if 0 is equal to mathf.floor of square root, well, is it? No, it's 0, and this is going to equal 3. Then it's going to loop again, it's 1. Hey, is it equal to this? No, loop again, 2, loop again, increase to 3. Is 3 equal to math's floor square root 3? Yes, it is. Okay, so what I want to do is we're going to reset counter back to 0. Set the target position X back to where it started from, which in this case is going to be a 0. So that means it's going to say, okay, we're going to come into here. Here's the first one. Here's number 1, number 2, number 3. Okay, is 3 equal to the floored square root? Yes, it is. Okay, target position is set to 0 again, so it's going to come here. It's going to bring the x position back to 0, and then it's going to go 0, 1, 2, 3. And then the next time it's going to go bring it back to 0, and it's going to go 1, 2, 3. This is how we get the x to set up. Now, right now, we're not changing the y position at all. So whenever we know we're done with this line, we want to increase the y. So we'll do target position dot y plus plus. It's going to go up 1 unit in the y direction. So it's going to do x, x, x 3 times. Oh, look, it's a square root. It's equal. Set the counter back to 0. Set the target position back to where we started, which was 0. And now increase your y position to 1. So now it's going to go to the next line. And I can show you all that right now as we do this. But, wait, we got to do this. Comment out the circle. And we'll do this dot square formation. Okay, come back over here. Wait for it to load. And we'll do... Click it. Okay, that's looking funky. So, got the first sphere. Zoom in a little bit. Move it up. Okay, that's your first sphere. Second sphere, then... Okay, so this worked accordingly. Okay, the y position worked, but the x didn't, because we're not changing the x position correctly. Okay, so what we're going to do is, let's see, so the target position right now is x. Well, we need to give it an offset. Like, we need to tell it, okay, well, we don't want it just to be this position every day, because right here, the x position never changed. If you look, we never changed the x position anywhere. Right here, the x position is set to 0. And then right here, 0. Come into here, nothing happens. Come here, 0. Like, it's just being 0. So we got to give it an offset. So what we'll do is we're going to come into here and do int x offset set to -1. Okay, well, why are we doing this? Okay, I'll show you. So in here, after we increment the counter, we're going to want to do x offset plus plus. So on the first iteration of this loop, it's going to come in here and say x offset plus plus. It's now going to be 0. Okay, so what do we do with this offset? Well, we want to add it to the x position. This is going to start moving it, but it's not going to give the results where I'm actually looking for. But I'm going to break it down for you and show you why. So it's going to increment 1 every iteration. So basically, you're going to have spheres that grow increasingly more distant from one another. See, look how funky that is. It looks weird. But as you can see, they're all actually starting to move. If you zoom out, you can see the difference here. It started here, further, 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 and further away. Well, why is it growing? Because we're not resetting that offset number. So right here, the offset is plus plus 1. What we need to do is say if x offset is greater than 1, go ahead and reset the offset to 1. And inside of here, we're going to do, if it's going to be plus the offset times, let's say 2. Like this. So what is this doing? So it's going to come into here, the first iteration, and say it's -1. Come into here, loop. Now it's 0. Is 0 greater than 1? No. What's 0 times 2? 0. Plus x, 0. Well, good. We don't want the first iteration. We don't want the first index to move. Now let's go to the next sphere in the square. The next sphere is now going to be x offset plus plus. That's 1. Is 1 greater than 1? No. 1 times 2 is what? 2. 2 plus the target position of what it's currently at is 0. So now it's going to set target positions x to 2. So now it's going to generate another sphere 2 units to the right of it. Okay? The next loop, it comes in. It's going to say, okay, this is now 2. Is 2 greater than 1? Yes. So reset it back to 1. 1 times 2 is 2 plus the current target position we had. The current target position that we had was 2. 2 plus 2 is 4. So you should have a sphere drawn at 0x, 2x, and 4x. This is going to help it remain consistent so it doesn't constantly grow longer and longer and longer as it goes. See that? That's exactly what we want. So if you look at the first one down here, okay? Look at the first one down here. And it's at 0, 0. The next one should be 2x. And of course the y is not going to change, and the next one will be at 4. And then now we're going to go up by 1 and reset the x back to 0. And then that's going to be 2 and 4. 0, 2, 4, 0. Now, if you want to give an offset because you don't like the way these touch on the y-axis, we can give it offset in the y. It's actually quite simple. We don't even have to go through the whole process of doing that if you want. Basically, what you can do is inside of here, you can do, instead of just plussing it by 1, you can do plus equals, you want the 1. Okay, you want it to always go up by 1 no matter what. But we'll give it an offset of like 0.25. So basically what this is going to say is, hey, the current position you're at, if you're at 0y, go up by 1 and then 0.25. So go to 1.25. And then the next row will be 2.5. And we can verify that here. It's however you want to put it. There you go. Now you can see that there's an offset in the y direction here. So now it's actually looking pretty cool. Yeah. That's pretty cool. So this is interesting because if you have an RTS game, okay, you want to make a real-time strategy game. You got units clicked and you got them queued up inside of a list, and you right-click on this map and you want them to move over here and then get into this formation, then you can do that. All you would have to do is check this out. All you would have to do is, now that you've gotten these target positions, you just give it to each one of those inside the list and have it move to go stand at that target position. So basically, instead of just hitting the square formation on start and it just populates like as if it teleports onto the scene into this formation, you can just have the units walk, and then this is their target destination. This is how you want them to end up. That's all it is. Just have them move. I hope you enjoyed the tutorial series so far. I enjoy doing the math. This was concepts that I learned when I was in college for game development, and we had some projects and we needed to be able to do things like this. And our final project, I went and made the formations for the RTS game we made as our 2-year project. And and what we did was I made a square formation and a circle formation. This is the same code, close to the same code I had written back at the end of the school for the formations used in that game. So I thought it was really interesting, and putting these concepts out there on YouTube, I really enjoy it. I'm glad I get to do these things, and you know, there's a lot of ways you can branch off with this. If you just want to have a list of game objects here, you can just put a list here. That way you don't have to instantiate them. So like if you left click drag on the screen, now you got 10 units. Those are 10 game objects. Then you'll come into here and just say, hey, square formation, square root of the list dot units dot count, and then you're gonna do the count right here. And then instead of instantiating the instance, all you're gonna do is you're gonna come down here and say current object in this list dot transform dot position set to this, and then it's gonna go and pretty much teleport there. But if you want it to move over time, then you'll know how to go in there with your scripts and everything. You can just give the object that instance of a unit a target destination to move to, and then just tell him how to move to it, and then that's the position he goes to. So that way the unit doesn't know exactly how the formula was created. He just wants to know, hey, where am I going? You give him a vector 3 and he goes to it however you coded it to go. So it's just one of those cool concepts I learned in school and wanted to share it out there with the world. I hope all of you enjoyed it. Uh, Let me know if there's any other ones that you guys would like. I enjoy putting out the content. I enjoy coding, and thank y'all for the subs and for sticking around. So y'all enjoy the weekend, and I will see y'all later.